Hi. Azure Machine Learning Service provides various ways to train your models. You can use the Python SDK, or you can also leverage the low code features like the Visual Designer or the AutoML to train your models. I'm going to focus more on using the Python SDK. And in this video, I'm going to show you one of the training methods available using the SDK. Okay, I'm going to show you the command function. So this is one way to train your models. Um, and I'm also going to show you how to extend this particular training method and perform hyperparameter tuning as well. In a future video, I'll show you how to build a machine learning pipeline and then use it. But in this video, I'm just going to focus on this particular training method. Okay, so let's get started. So let me go to the Visual Studio Code. So I've created a compute instance, and then I've established a remote session. Like compute instance on Azure ML, and I've established a remote session. So in the previous video, I showed you how to use MLflow, and then in that I've showed you how to, I've trained a scikit-learn random forest classification model, right? So I'm going to leverage the same code. So again, same code. So I've generated the dummy data set with 5,000 samples and then 20 features, and then I split that into training and test data sets, and then I've initiated a MLflow run, and then I've used the MLflow to log the parameters, created a random forest classifier object by passing in the required parameters. I've used the training data set to train the model, and then I've made predictions, calculated the accuracy metrics, FN score, and then logged it using MLflow. I've also generated the confusion matrix artifact and then logged it to MLflow tracking server. And finally, I've this code. So I'm going to save the log the scikit-learn model as well. Okay, so few things that I've changed from the previous video is I've leveraged the argparse module and then created few command line arguments, which which helps run this particular Python script from the CLI. Okay, so I've created four arguments here: the number of estimators, maximum depth, minimum sample splits, and random state. Okay, so in order to run this particular Python script, right? So what you can do is we can just say python train.py, and then let's use 150 as the number of estimators, and then let's trigger a run. Okay, it takes a minute or two for the run to finish. Finished running. So let's go to the Azure ML workspace, and then let's go to the jobs, and then refresh the job. So we see this particular run. Since we didn't provide any experiment name, we didn't set any experiment name. It defaulted to it used the default as the experiment name. So one thing that you've noticed, right? So I also haven't set any MLflow tracking server here, right? So whenever you're running on Azure ML Compute instance, you don't need to set the MLflow tracking server. So if you're running on the Azure ML Compute instance or the clusters, it knows that it has to use the basically it uses the environmental variables and then sets the tracking server to the Azure ML workspace. Okay, so that is the reason it kind of worked without doing anything, right? So let's go to this, right? So they said, right, it goes to the default experiment, and then this is the run. So we said 150 as number of estimators, and that's what you see here from the MLflow tracking UI. Okay, all right. So let's go to the Visual Studio Code again, right? So now we made this script runnable from the CLI, right? So I have this another Python module, I named it as command job. So just to show you how to use the command function. Okay, so in here, so I've imported the default Azure credentials, and then one thing that I've imported here is the command function, right? So this is This is what I was referring to, when I say the one of the training methods, right? This is the command function. So if you look at the command function, so basically the command function creates a command object which can be used inside a DSL.pipeline function. So basically, DSL.pipeline function is a way to create the ML pipelines, which again I'm going to cover in a future video. But or can be also be used as a standalone command job, right? So this is what we're going to do here in this video, right? So we're going to create a command object and then run it as a standalone command job. Okay, so that's the reason I've imported this particular function. And then I've also imported environment, build context, and manage identity, configuration entities. Okay, so let me run this particular cell. Let's import the libraries. Let's So I've created the ML client here, and then I have a prefix defined, and then I have I'm creating few variables, the environment name. I also have a user assigned managed identity created, and then a compute cluster. Okay, so I'm going to run this command job on an ML, on a compute cluster. So if you go to the Azure ML compute instance, um, so I have a compute cluster created with two nodes. So currently the two nodes are idle. Okay, and then if you scroll down, I've also assigned a managed identity. I've assigned a user assigned managed identity here. So for this particular demo, I've created a user assigned managed identity. So if you go to the resource group, I've created a user assigned managed identity, and then uh, you know re- I've assigned the ACR pull role to this particular user assigned managed identity. Haven't assigned any other roles, because we're not going to connect to any data stores or key vault or anything like that in this particular example. But just make sure that this particular user assigned managed identity is given the right permissions. I'll share the links to some of the Azure ML documentation, but user assigned managed identity or the system assigned managed identity uh, would have to be assigned to this particular compute cluster, because the compute cluster is going to use it when it connects to the other services. Okay, all right. So let's go to the Visual Studio Code again, right? So this is the client ID. So if you go to the user assigned managed identity, this is the client ID, and then the compute cluster name. Okay, so have that, and then I'm going to create an environment. Okay, for this environment, right? So have a I'm pointing to the build context folder. So look at this build context folder. I have a Docker file with Python 3.11.14 version, and then I'm going I have a requirement.txt file which I'm installing within this particular image, container image. Okay, so I've created this particular environment. Let's go to the Azure ML workspace. And then, if you go to the environments, you see this particular test train environment, right? So this is what we're going to use in this demo. Okay. Okay. So now I'm going to create a um, command object here, right? By using the command function. So if we go to the Azure ML Python SDK, the API reference, right? So let's go to the if you look at the functions, there is a command function, and then it expects various parameters, right? So you can pass all the metadata like the name, description, properties, and then you can pass the command, which is the CLI command, the environment that this job will run, experiment name, any environment variables. You can also pass the compute target. Two important things that you can pass is the inputs as well as outputs. Okay, so inputs could be like primitive types, like the for example, in this example, I'm going to use the number of estimators, max depth, min sample splits, right? So I'm just using the integer data type there. But you can also pass the input object as well. So input object meaning you can pass the data data asset paths, or URI folders, URI files as well. And then you can also specify the mount type for those data sets. Since in this example, I'm not using any data assets or data from the data stores, right, or even external data source, right. So I'm not using it, but in if your Python training script uses any of those, right, so you can pass it as an input object to um, the command function. Okay. All right, and again, you can also specify the outputs as well. If you want to save any output from your training run to, you can also do that with the output object. Okay, and then you can also specify the instance count. Let's say if your training run needs more than one instance, right? So you can also specify that, even the instance type. And then finally, you also need to specify where that particular Python script is located, and other details as well here. Okay, so if you go to the Visual Studio Code again, right? So what I've leveraged is, I've created an inputs parameter here and then I'm hard coding the argument values. I'm going to use the environment that we just created, right? So you can use that at latest tag to make to always use the latest environment version. Okay, and then I'm specifying code to the current directory, and then this is my Python script. Okay, and then if you look at the identity parameter, right? So you can use the manage identity configuration, AML token configuration, and then user identity configuration, meaning you can also pass your user identity information to this particular job. But whenever you're running on the compute cluster, it's better to use the managed identity than anything. Okay, because the use, like, based on my testing, right? So even though the user has access to the Docker image on the container registry, um, it's not being used. So you need to make sure that you assign a user assign managed identity to the compute cluster, and then provide the required permissions in order for this command job to run. Okay, so once you create the command command job here, right, you can just run it. Okay, so first let's run this particular command job, and then what you can do is you can give the command job name. You can also provide an experiment name, and then I'm passing in the compute cluster. Okay, you can also provide the compute name as part of the command function. But I think from a best practices standpoint, I believe it's best to pass it from the when you create the job. Okay, so let's run this. So it's going to take a few minutes to run. So basically, what it's doing is it's going to um, package these particular files, upload to the data store, and like zip it and then upload it to the data store, and then it's going to copy it to the compute clusters temporary folder, unzip it, pull the Docker image, the environment from the container registry, and then execute your code. Okay, so let's go to the Azure ML workspace, and then let's go to the jobs, to experiments, and then you see this particular experiment. This is in a running state now, and if we go to the um, run, right, so you see the command that we ran, and even if you look at the job type, it says command, right? So this is running, and then it's going to log the metrics and parameters as well. So it takes a minute for the job to finish. So it finished running, right? So as you can see, right, so this is the experiment name, this is the environment that we have used, and then this is the compute target. So if you don't provide the compute cluster details, right, so it's going to use the serverless compute, and then but to in order to use the serverless compute for this command job, you need to make sure that you assign this particular user assign manage identity at the workspace as well. Okay, so when we created the Azure ML workspace, we have created a system managed identity, but you can also assign user assigned managed identities to the workspace. Yeah, I'll share the links to the documentation, but some just keep that in mind. Otherwise, this job is going to fail when you use the serverless compute. Okay, all right. Cool. So we're able to run this command job, right? So we're able to leverage the command function, and created the command job, right? Uh, the beauty, like, one thing you can also do with the command job is, for example, I can just say command job, and then I can I can update the parameters. Okay, for example, max depth to 5. Okay, and then I can run the same job. Let me copy this fully. Okay, and then now I'm going to give this name here, and then let me run this. Okay, so basically I've just used the same command object, right? But I've overridden the inputs here. Okay, so it takes again a couple of minutes for the job to finish. Okay, let's go to the Azure ML workspace. So the job finished running, right? So if you click on this particular run, you see the estimators and depth, right, which we specified as 105, right? So we are able to kind of pass those parameters, right, by overriding the inputs, right? So basically, you can kind of do this with command object. Okay, all right. So in the previous video, I've also showed you how to use MLflow and then log all of your nested runs by simulating a simple, hyperparameter tuning run, right? So we have created we have leveraged the parameter grid from scikit-learn. We specified a set of, values for all of these hyperparameters, and then ran we we created a for loop, and then logged each of those child runs under the parent run. So if you look at, right, so we have used a nested run, and then we have a parent run, right? So again, the same logic, same code, right, which does the random forest classifier model training, right? But uses different combinations of these parameters, right? So so we can kind of do similar thing with what is called a sweep job within Azure ML. Okay, so let's run this again, right? So from so what I did was, everything is the same, except I've imported a choice class from the sweep module here. Okay, I'll show you. So let me just finish running this. I'm going to use the same environment, same cluster um, as well. And then I'm going to create the same command job like what you saw previously, right? So here, what I'm doing is I'm creating a new command object here. Okay, and then within this command job, right, so I'm using the choice to specify the search space. Okay, so if we let's go to the so whenever you're creating a hyperparameter run, first you need to specify the search space, right? So like your parameter combinations, for example, right? So those becomes your search space. And then you can also specify the sampling algorithm, and then you specify the objective, right? So do you want to minimize maximize your accuracy or minimize your loss, right? So you can specify your objective function. You can also specify your early termination policy, right? You know, and then you can also specify your resource limit, maximum number of trials that you want to run, maximum concurrent trials you want to run, and you can also specify the timeout or the trial timeout as well, as part of your sweep job definition. Okay, so I mean, if you go to the documentation, for example, and if you go to the custom training hyperparameters, so there's a good amount of documentation here that touch upon these topics. Okay, so you define the search space. You can specify discrete hyperparameters, or you can also specify the continuous hyperparameters. Okay, with the different distributions, and then you can specify. You can choose a sampling type. There's few sampling methods available: random sampling, grid sampling, and then Bayesian sampling. In this demo, I'm just using the grid sampling. Okay, and then you can also then you specify the objective function. Do you want to minimize a particular metric or maximize a particular metric? Okay, and then you can also specify the early termination policies, right? So if you want to end a poorly performing job early, right, so you can do that as well with the termination policies. Again, there's various policies available. And then you can also set the limits, like you want to, as I said, right, so you can specify the maximum number of trials that you want to run, concurrent trials, or other details as well. Okay, and then you can then run your command job. Okay, all right, so that's what I did. I defined the search space here. Okay, so let's run this. And then the command job, and then sweep, right? So if we go to the documentation, again, the API reference, and then if we go to the command function, we have the command object, right? And then you go to the methods, sweep. So this is what you are using, right? So it converts the command into a sweep node with extra sweep run settings. So basically, you're able to, you can also specify all of these details, right? So your sampling algorithm, your concurrent trials, your metrics, and all that here. Okay. So one thing that so I'm specifying the grid sampling algorithm. I'm specifying the metric, right? So and then the goal, right? So basically, this becomes my objective, right? So you need to make sure that this particular accuracy metric is being logged using MLflow, right, with the same name, right? So otherwise, it's not able to use it, right? So in this demo, in this example, at least, right? So I'm logging the accuracy as accuracy, like I'm naming that as accuracy, right? And then I'm using that as my primary metric. And then my goal is to maximize that particular accuracy. I don't have any early termination policy, but you can specify that. And then finally, I'm specifying the maximum concurrent trials, right? So this is another important thing, right? So if you, let's say if you have high concurrency limit set, right? And then you have a compute cluster with 10 nodes, right? It tries to use all of those nodes on the compute cluster. Okay, so just be careful, right? So before you run this particular hyperparameter tuning, and just make sure that you're using the right size compute cluster. Otherwise it would just use all the nodes on the compute cluster. Okay, and what I've noticed is each compute node can only run one job at a time. Okay, so you can't have multiple jobs with this particular setup. Okay, all right, so let me run this. And then finally, same as the previous command job, right? So we're going to run the job. We're going to give it a name, and then we're going to run it on this particular compute cluster. Okay, so let's run this. Okay, so it started running. So it's going to upload all the files to the blob store again. Do the similar work, right? Let's go to the Azure ML workspace. Then go to jobs. You see there's a new experiment, right? Which is the sweep job. And then if you look at the job type, shows up as a sweep. And then if you click on that particular sweep job, you see the three runs. There's going to be more runs, but since we specified the concurrent trials as three, right? It started these three jobs, right? And once these three jobs are finished running, it starts creating new trials as well. Okay, so it takes a few minutes for it to complete. We'll come back once everything is finished running. In the meantime, as I was saying, right? So if you want to use the compute cluster, right? Again, just make sure that you create the user assigned managed identities or leverage the system assigned managed identity of the compute cluster, and then provide the required permissions. Okay, and then if you are using a serverless compute, just make sure that you create a user assigned managed identity, and then associate that with the workspace. Here is um, this is some code from the documentation, right? So you can assign the user assigned manager entity to the workspace. If you, and just make sure that you provide the permissions like ACR pull, or if you are trying to connect to the key vault, right? Just provide the right permissions. If you're running on a serverless compute. Okay. All right. Let's go back to the Azure ML workspace. Okay. So this is still running. Again, let's give a few minutes. Okay. So it finished running. So let's expand this. You see all the trials. All of them are specific. The job type you can see as command job. And then it also highlighted what is the best run based on our objective for the hyperparameter tuning, right? So let's click on this sweep job. Okay, so and then let's click on the trial. So you can see the parameter sampling methods, the early termination policies, the primary metrics, all of that we configured from the code, right? So you can see that. Then if you go to the trials, it shows you all the trials with the uh, you know um, the hyperparameters that you for each of those trials, and then the accuracy score, right? So you can see that, and then you can also look at the metrics. It also provides you few visualizations that you can leverage. Okay. All right. So this is how you can perform hyperparameter tuning, and then you're able to kind of live again, you can leverage the Azure ML workspace to do this kind of hyperparameter tuning. So you don't need to configure anything, right? So all you need to do is just make sure that you create a separate training script, make use of ML flow, and define all of your hyperparameter related policies, and then trigger the run, and then you should be able to see all these runs here. you know all right. So in this video, right, so what we did was we created a command job, right? And as I was saying, right, so for a command job you specify the code, the command that you also that you want to run, the inputs that goes into that particular command, the outputs that comes out of that particular run, right? The environment, right, which is your runtime that's needed to run your job, and then any other metadata, right? The experiment name and the compute details you can provide it from the when you trigger the job. Okay, and then you can leverage the same command job, and then you can create a sweep job, right? um, you know Basically you can then create a hyperparameter tuning run, right? For the sweep job you specify all of this, like the search space, sampling algorithm, objectives, resource limits, and things, and then you should be able to trigger a hyperparameter tuning run. Okay. All right. So in the next video, I'm going to show you how to create the machine learning pipeline. So this, which is another method of running your training runs. Okay. Thanks for watching.